Additionally, we add the correction factor to the measured EVD, CVD, to eliminate the time lag for manual measurement of control vertical temperatures. Generally, we follow the practices of life extension of the battery by monitoring health quality, monitoring the health of the battery, and operational discipline, and finally with the reviews. We at RINL, for 5 batteries, we are having only one common adjuster section line through which we maintain the battery section for all the batteries. And we use to maintain GCM pressures from 17 to 20 mm water column, depending upon the working period of the battery. And we ensure the slight positive soul pressures at the end of working period. And we also ensure the positive vertical top pressure by maintaining the chimney draft. We are having one index that is called pushing regularity index. Generally, what the schedule which has been given to the battery operation for leave the ovens empty for longer time, and degradation or burning of graphite here inside the oven. Heating work and finally those are preventive maintenance, because once we lost the time, we have lost forever, be the production. So all those maintenance schedules are as per SFP. And in terms of heating operations, this finish of all reversing valves and releasing of reversing valves, washers cleaning, generally that is also cleaning, risers cleaning, grouting of flues, radiator blowing and stripping, burst through canal cleaning. Burst through rope working, in vertical banana adjustment, checker bits relating, full inspection of total battery. Generally, this is done half yearly, and restoration of damaged flues by inserting pipe. What we have done is recently there are 20 flues. Battery number 3 we have got which it was what we did. We have inserted boiler pipes inside the flue to bypass that damaged portion in the ridge area, and we have survived. We have revived those flues, and those flues are working properly. And we do sealing management by mechanized or manual, electro-manual cleaning of cleaning and regulation of doors, daily checking of keyboards, latches of doors. This we check every day, and scheduled door changings around 30 to 40 doors we plan for changing in every month in per battery. Tar cutting at oven sol. This is done just after pushing of the ovens. Oven top gas offsets maintenance, then the gooseneck cleaning of gooseneck, wall box cleaning, stand pipe cleaning, charging of hats cleaning, charging hats cleaning, and processing of plates. These are all scheduled jobs what we do religiously, because we are running the dielectric battery, older batteries. special care. Refractory care. Ovens are inspected for wall cracks, bulgings, carbon deposits, sole brick damage. These are to avoid artifices. Dry grinding of ovens. These are remedial actions we used to take for correcting those heating walls, dry grinding, ceramic welding, oven dusting. For minor cracks, hairline cracks, we used to do the oven dusting for sealing those hairline cracks. And silica or fire clay polish work. Wherever we find that holes which has been which can be managed by patching of the silica paint, we go for silica patchwork. And in vertical repairs, we prefer in vertical repairs, but since it takes a lot of time, almost 30 to 40 days, so repair, full wall repair, and finally we ensure to eliminate these problems, especially this is happening in the in vertical area. So we ensure proper in vertical temperatures in the in vertical area. We means that wall damage once we have lost one zone. Presently, we have started force gun applications as I was told. We have started in oven number 460 and it was completed yesterday on both sides. We hope that it will give it will last long and it will give a good relief to us. This is the summary of our batteries. Battery number 1 is 37 years old, commissioned in 1989. In 1999, we have gone for 52 floors in vertical repair, and in 2015-17, we have gone for 14 in vertical, and in 1921, we have gone for 13 in floors. And 2022 till date, we have gone for 26 in verticals. Full wall repairs we have done in between, which is the 2005. 68 heating walls we have gone missing that, but we have gone for full wall repairs.
One point to add here is RINL has never gone for cold repair of all these batteries. Only one battery has been taken up for cold repair in the year 2000. So we were running the oldest batteries in the country. We proudly say because so that current scenario which we are facing, everybody here in the hall knows RINL is facing a lot of challenge in doing the pushings. Without cold repairs or complete battery shutdowns, we were maintaining the oldest batteries. That one point we can say proudly in front of all of you. That Hudhud scenario, Hudhud was a cyclone which we have faced 7 days no power. So no gas supply to coke oven batteries, and without a single sticker, we pushed all the ovens. So at that time, 4 batteries were in operation. All the 4 batteries were successfully pushed out without any single sticker. So that scenario, no country, no steel plant in the world might have faced it, because 7 days no power. No power, we have completely sealed the battery. A single point of air not entered into the battery. So we have taken such care, and running the exhauster without coke oven gas. So how to start the coke oven gas without with nitrogen, and the challenge which we faced, the small amount of heat left out in the battery has been utilized to charge 1 or 2 ovens and push out. So running the exhauster with that gas level is very difficult. So one more challenge, because rather than this presentation, I want to share our experiences. So we have commissioned battery number 5. Battery number 5, and tomorrow I have one more presentation. I will show how long the gas line is. The exhauster is connected to, same exhausters are connected to all 5 batteries, and the 5th battery is 1.8 kilometers long. So we have to manage the suction of the exhauster for a battery which is 500 meters long and a battery which is 2 kilometers long. So maintaining the exhauster suction was a difficult challenge which we have faced. So that is one big experience we have learned. So commissioning a longest suction line and handling hudud, and then this oldest batteries operation without cold repairs, and these are all the things which have been of late we have learned a lot from these things. So everybody can be that means our experiences you can get on share also. So these are in general equipment reliability, all the machines. So time machines repair has to be done for better the discipline of the coke oven and battery life extension. Machine availability and machine maintenance is most important, which we have to take care. Emission controls, never allow any flame to come out of the door, never allow flame to come out of the charging lids. So slight indisciplines will lead to very big catastrophes. So if the charging lids, whatever you charge and close the lid, our batteries are all top charging batteries, we don't have stamp charging. So all 5 batteries are top charged only. After closing the lid, because how to extend the life of the battery? To extend the life of the battery, discipline of the worker is the most important phenomenon. So after charging, closing the lid, loading the lid with the silica masala and all, if something is neglected, the CTRs which are adjacent to the charging lids, they will start elongating. Once they start elongating, your buckstay gets deviated. Once there is a deviation in the buckstay, it is a permanent failure. So now these all things will lead to a very big challenge. So we have recently faced the problem of GCM coming down. Actually, GCM, which has to be at a fixed level, has come down, and tar started accumulating in the GCM. So this tar removal and all, it's very big difficult task. GCM has to have a slope like this, but our GCM became like this because of the heavy weight and the buckstay deflections and all. So evacuating the tar couldn't have been done, and we have dismantled the GCM, and we erected the GCM recently. One GCM in a hard condition only. We haven't completely shut down the battery. So discipline is very much important for the long extension of the life extension of battery. And oven top cleaning. First, nobody should neglect oven top cleaning. Whatever coal dust is lying on the floor on oven top near the lids or somewhere else, it shouldn't be left. That first point that has to be taken care. That will give highly beneficial life for the battery. Frequent charge level measurement, leveler bar deflection, these are all the things everybody do. There is nothing new in telling these points, but everything, minor things will have bigger effects. So we anchorage. Anchorage is the main part which will help the battery. So at Vitex Steel, all the batteries are similar. Hence what we do is we follow this methodology in anchorage setting. Once in 3 months we check the CTR measurement. So CTR, we are maintaining one side springs are there for the newly constructed batteries, and we maintain around 13 to 14 tons of load on CTRs. And LTRs, we have 6 LTRs per battery, so 36 to 40 tons on each side of the LTR is being maintained. Once in 6 months we check LTR auxiliary springs and all the things. So this is the anchorage part. Anchorage is equally important to the refractory. Next. Housekeeping, what I have told earlier. So process monitoring. So these are all the things which we monitor in the shifts. GCM pressure, heating air pressure, waste gas draft, regenerate draft, cycle time consistency, GCM temperature, steam HPLA consumption. All these things are monitored every time. And coke mass readiness is one which has to be checked by the person who knows about the battery well. So coke mass while pushing has to be monitored by every engineer of coke oven. So at least in one shift, if you monitor 5 to 6 coke pushings, you will know what is happening in the battery. So rather than relying on the temperatures and process controls, physically checking the coke is more important than anything else. So every engineer spends some time at the coke side, and the coke side is the area which you have to focus more rather than on the pusher side, because coke side generally people will neglect. So all the glazings, all the gasings, everything will be on the coke side. Front side, everybody will take care. Everybody will show front very well. So people have to take care on coke side. So all the engineers, I request you to go to coke side and see it. Next. So our blend formulation, we generally prepare a presentation only with respect to the heating part. Blend also, what we do is we are completely importing. We don't have any indigenous sources of coal. So 60% we are using hard coking coal, 40% we are using soft coking coal. So both coals are being imported, and based on what we have, the tough situation being faced in the organization, the financial crunch, we are going up to 50-50 or 55-45 also. So slightly we are facing the problems of fights. So that is also being handled technically by our teams. Thank you very much. So good practices of design, heating and operation as well as preventive maintenance are keys to limit damages to the battery. Thank you very much for giving us this opportunity.
Thank you.
I have a query, not related to presentation. Your D car is moving both the wheels of the D car, both right, in the bench road itself.
Yes, sir.
So it is the falling in the box stand.
Yes.
How we are
It is following the workstay, it is following the DE
Yeah.
top GCM brackets.
maximum
So
bracket. Yes.
we have completely removed one GCM DE trolley line. DE trolley line for battery number 4. So
What frequency you are changing that track, bucket car track, D car track line?
yes.
What frequency you are changing the D car track line?
Okay, this is not, means, it should not run for further, because we will do survey also. Survey of, means,
Your D car is of design,
yes, yes.
similar same design, na? Okay, thank you.
अब मैं टाटा स्टील जमशेदपुर की टीम को आमंत्रित करता हूँ अपने प्रेजेंटेशन के लिए। This will be the last presentation for this session. Remaining presentations will be going to one more. I think it's a long session this morning we are speaking. Good evening once again. So this is a case study for a particular battery, that is battery 1011, wherein we have done some PTCL to defer the deterioration of the oven holes. So I'll skip the introductory slides. So these are some of the defects that we were seeing on the wall. So erosion seen at third to fifth layer from the bottom, and near the top latch in the upper zone of the oven. So the battery was commissioned in at around 2012, and these deteriorations we were seeing in the battery in 2015-2016. So what we found was that the pusher head was of 500 mm, and the battery at the pusher side, the battery width was 524. So there was a clearance of only 12 mm on both sides, while in the previous batteries that was auto designed in battery 8-9, so the oven width was at pusher side, and the pusher head was 390 mm. So there was a 30 mm clearance at both sides. So what we decided to do was that since we were seeing these marks and it was quite clear that the pusher was fouling with the wall, so we reduced the width of the pusher head so to 470 mm, and after this also we found that there was some erosion on the. So the next step that we took was reduction in the width of stamping box. So the stamping box width initially was reduced by 15 mm to about 485 mm to reduce the wall pressure during the carbonization and defer the deterioration of the oven walls. Then even after this, we've found that the erosion of the walls in the RAM side, especially in the first and second flue zone, was not. We were still facing problems of erosion. So there, what we did was we taking cue from the push force visualization model. So we found out that the peak push force of the ovens was quite high. So for that, we changed the logic of the pusher. So like you can see, it was increasing in steps after touching the coke mass. It was increasing from 10% to 20% to 30%. So for a particular zone up till the fourth flow, so we reduced the pusher speed to 10% of the reference speed. And by doing this, there was a reduction of about 40 to 50 kilowatts of 40 to 50 kilowatt peak push force reduction was seen. Then after doing this, we could not completely come out of the problem, and still we were facing issues of wall damages in this zone. So the next step, we again went back to the design, and we found that while we had reduced the pusher head width, but the U guide which was, so that was kept at 490, and the side guide plate which is at the bottom, so that was also at 500 mm. So now what we have done is the entire pusher head along with the upper U guide and the bottom guide. So everything we have made the design changes, and we have reduced the width to 470 mm. So now we get a clearance of 37 mm. And by doing this, we have seen that now the frequency of the damages of oven wall has reduced significantly. So this was one of the projects that took a lot of time, but step by step, by doing PDCA, we could achieve the reduction in the damage in the oven walls. Thank you. And one more topic is that oven wall scanning through laser scanner, which Fosbel already presented. So recently we have done this in two of our ovens. Is oven number 50 and oven number 1104. So these are the results. So if you see, so no significant erosion has been found. Some places there is a bulging, and that is due to the carbon deposition on the wall. Thank you.
Yeah, actually, yeah, push force visualization model to go ahead.
Yes.
So can you kindly explain that? I'm not able to understand. Basically, push force there is a curve. You can see the scattered plots like things on that. Push force visualization model.
Yeah, so push force visualization model. So push force आप individual ovens का जो है, individual ovens का आप इस तरह का आपको ग्राफ दिखता है जो लेफ्ट हैंड साइड पे है, बट वो राइट हैंड साइड पे जो आपको ग्राफ दिखता है, सो उसमें क्या है कि आप जैसे मंथ सिलेक्ट किए, एससीपी मशीन सिलेक्ट किए स्पेसिफिक, तो उसमें सारे ओवेंस का पूरे मंथ का डेटा आ जाता है। तो वहां से आप देख सकते हैं कि कौन सा ओवन कौन से सेट ऑफ मशीन के साथ हायर पुश फोर्स दे रहा है। अकॉर्डिंगली आप उस ओवेंस के लिए करेक्टिव एक्शन ले सकते हैं। सो वो पिन पॉइंट कर देता है प्रॉब्लम को कि कहां पे आपका एग्जैक्टली ज्यादा प्रॉब्लम है, एंड व्हिच इज द प्रायोरिटी जोन वेयर यू नीड टू फोकस।
Actually, green ones are the ovens which are taking higher push force.
No, green ones are okay. Green and blues are okay. Yellow onwards, you need to, the red and the black category जो रहता है, so those are the priority ones, and followed by red, and blue and greens are okay.
So for the ovens taking higher push force, what are the measures you are taking to reduce it?
ओवन जिसमें ज्यादा पुश फोर्स लेता है, उसमें पहला चीज हम लोग चेक करते हैं कि वॉल का कंडीशन मेरा कैसा है। अगर वॉल में मान लीजिए कहीं कुछ कैविटी वगैरह हो गया है, तो उसके चलते कोक मास अगर वहां पे फंसेगा तो हायर पुश फोर्स लेगा। तो और उस
एमटी छोड़ने के दो तीन एमटी जब छोड़ते हैं,
हाँ,
उसके बाद में लेते हैं।
आपने ये पुशर आर्म को ट्रिम किया है,
हाँ।
इसकी वजह से नॉर्मल ओवन में पुशिंग करंट कैसा है? जो प्रॉब्लमेटिक होम्स में तो ठीक है आपने बताया।
हाँ नहीं वो सबके लिए ही किया है, मतलब वो तीन सेट ऑफ मशीन्स है हमारे वहाँ पे, और ये जो प्रॉब्लम हम लोग को पीक पुश फोर्स का आ रहा था, ये पीक पुश फोर्स का प्रॉब्लम सारे ओवेंस में था, और ये चेंज करने के बाद वो सारे ओवेंस में ही ठीक आया है अभी। सो अनलेस और अनटिल देयर इज अ कैविटी, मतलब ऐसा नहीं होता है कि कुछ ओवेंस मतलब एब्नॉर्मली हाई पुश फोर्स ले रहे हैं।
थैंक यू। और आज के सत्र के समापन के पहले मैं अपने सीसीएम कोकोवेन भास्कर प्रसाद सर से निवेदन करूंगा कि वे हमारे जो इंडस्ट्रियल एक्सपर्ट के रूप में जो आए थे लोटस और कॉस्मेट टीम को फैसिलिटेट करें सर प्लीज। तालियां बजती रहनी चाहिए। धन्यवाद सर। आज का ये सत्र कल कंटिन्यू रहेगा। करीब 4 टीम जो है हमारी आज प्रेजेंटेशन नहीं कर पाई है, तो कल हम लोग शार्पली सबसे निवेदन है कि 9 बजे हम लोग जो है सेशन को चालू कर देंगे। और अंत में मैं अपने सीएम सर से निवेदन करूंगा कि 2 शब्द सर।
Thank you for public participation. सब जितने भी this is the occasion जहाँ पे probably I don't know इससे पहले भी बहुत बार ऑपरेटिंग कमेटी हुआ है, but 100% participation from all the steel plants. ये तो मुझे हाईलाइट ऑफ दिस सेशन लग रहा है। कभी किसी भी ऑपरेटिंग कमेटी में आई थिंक कोई ना कोई प्लांट मिस हो जाता है, लेकिन इस ऑपरेटिंग कमेटी में आई थिंक ऑल द प्लांट्स आर प्रेजेंट and everybody is participating very joyful and enthusiastically of the problems and बहुत सारे success stories को उन्होंने दिया है। There are so many highlights of this morning and speaker session में, जिसमें हम लोग काफी कुछ सीखने के लिए मिला। एक 2-3 चीज है जो काफी I think बोलने लायक है। एक तो ड्राइव फॉर सपोर्टिंग सिस्टम फॉर स्टैक इमिशन मॉनिटरिंग, वो मुझे बड़ा अच्छा लगा, क्योंकि ये this is a problem which is happening everywhere. In all components में this is a big problem, and अगर हम लोग ऐसा कुछ सिस्टम डिवाइस कर सकते हैं, लगा सकते हैं अपने बैटरीज में, this will be really a very good thing which is to be adopted in all the component battery stacks. दूसरा क्रशर का हैमर लाइफ यार हम लोग बहुत कोशिश किया। मैं यहाँ पे बोकारो में या फिर हमारे सेल प्लांट में या कोई एटलीस्ट 1,50,000 और 2 लाख उससे ज़्यादा नहीं जा पाता, and JSW Dolvi is going for 10 lakhs. This is huge. तो हम लोग चाहते हैं कि कुछ वहाँ से कुछ हम लोग को शेयर कुछ इनपुट करें। Similarly और भी कुछ इश्यूज थे, पॉइंट्स थे, एलपीजी वाला तो एक हमने बताया, लेकिन that is also मुझे लगता है heating up process में there was some issues जिसके कारण maybe temperature was not controlled during heating up, जिसके कारण फ्यूजन हुआ था लगता है। तो that Mr. Sabram has rightly pointed out. इसमें वो थोड़ा सा हिटिंग अप एंड कमिशनिंग का टाइम का इश्यूज कभी-कभी हो जाता है, एंड देयर आर अदर थिंग्स लाइक वैगन कपलर वाज वेरी दिस इज आल्सो वेरी इनोवेटिव, क्योंकि बहुत सारे एक्सीडेंट्स हैं ऑल ओवर स्टील प्लांट्स। हर जगह हुआ है, दुर्गापुर में हुआ है, बोकारो हुआ है, एंड भिलाई में भी हुआ है, बाहर दूसरे प्लांट में शायद टाटा स्टील में भी हुआ है इससे पहले। Everywhere this kind of thing is happening, and go to mechanical शायद hydraulic एक आर्म लगा करके you are maintaining the position of the coupler so that जब दोबारा वो वापस आए तो automatic auto coupling हो जाए and manual intervention कम करना पड़े। So that is a very good सस्ता solution है, क्योंकि मुझे पता है iRobotics and को लेकर के we have also tried for doing robotics, but this is a very cheap solution and very innovative solution. Very good. That is also a very good solution which we have got. and what else? Camera based restrictive zone would be many people have tried that, but that is a good thing to be implemented. Apart from that, camera based restrictive zone for back and pumping. And 3D laser scanning possible जो दिया है, which possible has told, and probably one of the standards also adopted that. Tata Steel working adopted it. So many times we go for end flow repair or maybe cold repair or whatever. We plan for brick purchasing of brick because the almost silica brick is not a kind of brick which can be taken off the shelf in minimum quantity. At least they want 1,000, 2,000 tons of silica bricks, which normally they don't give at a low cost. So उसके लिए पक्का assessment होना बहुत जरूरी है कि कितना brick is required. So उसके लिए this kind of laser scanning is done. FO cable, temperature measurement and control vertical flows. This is also with the help of robotics. This is also a very good project. Rotary drive, that is also one of the things which is a very innovative thing which I think Jasper Riker has done. Jasper Riker has done a rotary drive for coal drying during monsoon season. That is also a very good thing which has come up in this session. And I think that is all. And LiDAR-based system. That is also a common solution, but it is also a very good solution to be implemented for safety of all the people and equipment. So I welcome all of you in tonight at Bokaro Club Cinema Arena for the program dinner. आइए वहाँ पे थोड़ा सा enjoy करेंगे. Thank you.
धन्यवाद सर. आप सभी से निवेदन है कि डिनर में अवश्य पधारें. धन्यवाद.